This is number 5 from the 2007 exam. So we're given this table of values for R prime up here, and we're told that the volume of our spherical hot air balloon expands as the air inside the balloon is heated. So we've got the radius of the balloon being modeled by a twice differentiable function of time. Here is our domain. We know that the graph is concave down. That could be important. And we've got a table that gives us values of R prime. And we also know that the balloon is 30 feet. The radius is 30 feet when t is equal to 5, and they were nice and gave us the formula for the volume of a sphere. So for part A, we need to estimate the radius of the balloon when t equals 5.4 using a tangent line approximation at t equals 5. So let's write down our tangent line approximation. So this is when t is equal to 5, so we have t minus 5. And we know when t equals 5, r is equal to 30. And r prime of 5 is equal to 2. So we're going to use this approximation for 5.4. Oops, 5.4 minus 5. So r is 30.8, which means that r of 5.4, the radius at 5.4, is approximately 30.8. And that's going to be in feet. And then, is our estimate greater than or less than the true value? Well, we can say since the graph of R is concave down, we know that our tangent lines lie above the graph, so our approximation is greater than the actual value. So we'll say the is than the true value. Okay, so that's it for part A. Part B, we need to find the rate of change of the volume of the balloon. When t equals 5, indicate units of measure. So we know v is 4/3 pi r cubed, and we have to find dv dt, the rate of change of the volume. So it's going to be 4 pi r squared dr dt. So now we again know from the directions that r is 30, so we've got 30 squared, and we found before that the rate of change of r prime at 5 is equal to 2. So this turns out to be 1836, 7200 pi, and the volume is being measured in feet cubed, and time is in minutes. Okay, part C, we're using a right sum for the 5 subintervals indicated by the data in the table to approximate this interval here. All right, so for part C, we're approximating the integral from 0 to 12 of r prime of t dt using a right sum. So let's see. We do have 5 subintervals. Here's 1, 2, 3, 4, 5. 5. And so we're going to do base times height. So we've got 2. This is 3, then 2, then 4, then 1. But for each of the heights, we're doing the right endpoint. So we're going to do for the first one 2 times 4, then 3 times 2, then 2 times 1.2, 4 times 0.6, and then 1 times 0.5. So let's work on that. So 2 times 4 3 times 2, 2 times 1.2, 4 times 0.6, 1 times 0.5. So it's 8 plus 6 plus 2.4 plus another 2.4 plus a half. So what do we have here? 14 plus 4.8. So that should be 19.3. And now we have to state what this means. So this is the change in our radius in feet from t equals 0 to t equals 12 minutes. And now we get to part D. Is our approximation in part C greater than or less than the actual value? Give a reason. Well, we know that R is concave down. That means that our second derivative must be negative. So if our second derivative is negative, that means our first derivative must be decreasing. Now, if you have a function that's decreasing, the right approximation is going to be an under approximation. So we can say, therefore, the approximation is less than the actual value of our integral.